Okay. Quiz today. 2 questions, 2 bonus questions, 2 questions, 1 and 2, 2 bonus questions, 3 and 4. 3 and 4 there, a little more complicated than the bonus questions you're gonna see in the quiz. Open no quiz, so this is what you have on. Long division. When you set it up for long division, the divisor's on the outside. Everything goes underneath. So what's going out here?
+1.
X plus 4 is going here. And then the numerator is our division, x squared, neatly, for your own sake, minus 8x plus 3. Pretend you're an insurance agent. You want to give this dividend total coverage. Let's not be sloppy. What a sloppy I do my son to this. His handwriting's horrible. And you just focus on this first term, x, and that first term, x squared. What times x is going to give us an x squared? X. So the first thing we're going to multiply is an x to the first. X to the first, just an x by itself, should go in the x column, where you just have an x to the first. So I'm going to multiply by an x to the first. Now, when you multiply, you got to multiply both of them, because you're going to take this term times the divisor. So it's going to be x times that x plus 4, distribute x squared plus 4x. So right here, we get x squared plus 4x. And what's the next step in division? We subtract. This better cancel out, that's why we chose x squared minus x squared, 0. This is negative 8x minus 4x. So I have negative 8x, take away 4x, negative 12x plus 3. Questions? Because that's where people get a little, they mess up that subtraction. They mess that part up. Good. Then, since you started in the x column, the next column over, which is the last column in a binomial, the constant, you're now asking yourself what times this x is going to give us that negative 12x. So what times x is negative 12x? Negative 12. So the next term in the quotient is going to be a negative 12. So negative 12 times the divisor. So now you have to multiply by the entire divisor, so you're going to distribute. And if you have to do it over here on the side, then do it on the side of the problem. Negative 12 times the x plus 4. If you can go ahead and hopefully practice, if you want to just go negative 12 times x, and then negative 12 times 4, and then do it there without showing it over here, I'm okay with that. Negative 12 times x is negative 12x. Negative 12 times positive 4 is negative 48. And then we subtract again. Subtract, subtract. And when we subtract this time, it's negative 12x minus a negative 12x. So when we subtract the negative, it becomes a positive. Negative 12x plus 12x makes a 0. That's why we chose the negative 12 in the first place. And then 3 minus a negative 48 becomes plus 48. 3 plus 48, 51. X cannot go into 51, so that's my remainder. So you write your final answer plus the remainder of 51 divided by or over the original divisor of x plus 4. Now, on your quiz, down here at the bottom, you're going to have the original question, and it actually is going to look like this. I wrote it differently at the bottom. I wrote x squared minus 8x plus 3. And I wrote it like this to save a little bit of room so you have more room to work the problem. So I put it in parentheses, divided by the x plus 4. And then you put your final answer, x minus 12 plus 51 over the x plus 4. Have to have the plus before that 51 over x plus 4. Any questions? If the what was the negative? 51. If it was a negative, don't. Here's what I tell everyone. If you understand what you're doing, go for it. Try and challenge yourself. If you're hesitant and you want to play it safe, then just go plus and put the negative like that. Let's not run to make it, leave it to chance. If it was a negative, and then just put plus still remainder of negative 51 over there. Plus a negative, this will just be a negative. So if you did that, I'm fine. I see people mess that up. That's what I see. And I want you to do that. So play it safe, plus keep the negative there, we're all fine. Okay? It's on there, so make sure we don't get this speaking. That was a good question. All right, synthetic division. And you know what? I didn't do this on the first one. On the first one, I should have said, make sure it's in the right order, make sure all the degrees are present. It's like taking roll, like I did already at the very beginning of the class. And I'm not saying it anymore. If you came in after I took roll, make sure you check in with me before, because it's a 0. You guys are that walked in later. I have you absent. And if you don't check in with me, it's a 0 for today. If you check in with me, then you're late and get a 5. I'm done. I've got to figure out a way to not coddle anymore. I thought about this. If I was still coaching basketball, and I was like, oh, come on, it's going to be okay. We're going to really get through it. You know what? They're going to get eaten alive on the court by another team. Because the other team's not going to go, oh, come on, you're going to be okay. No, we're going to help you out. They're going to be slamming them to the floor. Especially those darn Celtics. I've watched their HBO special. They're able to beat the Celtics. Watching Magic play. Magic, he's a nice guy. Larry Bird, anything. Sorry, but it's great. Oh, great. Anyway, evolving. I can't, I shouldn't. Okay. New leaf. Make sure all the power's there, make sure it's in the right order. So on the bonus question, 3 and 4, obviously not in the right order. But we also want to check for missing tires. Anyway, the first 2, not going to be a problem. So since you're doing synthetic division, first thing we're going to do is identify the K. What's the K? Negative 3. Negative 3. Because in synthetic division, we're taking our polynomial, our P of X, that's P for polynomial, that's the the dividend, and we are dividing by something that looks like x minus k. So it's a built-in negative. Don't know how many times I said that this semester about built-in negatives. And the reason why, when you think about it, you're dividing by the entire denominator. And when you have things in parentheses, there's usually a built-in minus. So when you extract the value of k, it's the opposite sign. It's the opposite sign. So when you take out whatever you think k is, take out its opposite sign. So k is -3. So now you draw the box, you put k in the box, and then you write down the coefficients of the dividend. So what are the coefficients of this dividend up here? A 1, 5, and 7. We have a 1, we have a 5, and we have a 7. We have 3 terms, we should have 3 coefficients. Are we good? Okay. Then you draw a line. Draw a line, giving you some room to work because you're going to be doing some stuff in between. First thing you're going to do is you're going to bring down that first coefficient. You just bring the 1 straight down. This comes straight down, we get a 1. Then we multiply and add. Multiply times the box and then add. So we're going to take this 1, that 1 times what's in the box. So we get -3. And then you add vertically, you add. 5 plus -3 is 2. And then we multiply again, so we go 2 times -3. We get -6. And then we add vertically. 7 plus -6 is 1. The last term is the remainder. The first terms are the coefficient of the quotient. So the answer, this is the coefficient of the first term. It's a 1. The first term starts 1 degree less than the first power that you have in the dividend. We're taking x squared, we're dividing by an x to the first. If you have an x squared and you divide by x, what would you have? What power? X to the what? You have x times x divided by an x, what do you look with? And x to the first. So if you're starting with a power of 2 and you're dividing by a power of 1, you're going to end up starting the answer with a power of 1. If you start with a power of 5 and you divide by a power of 1, your answer is going to start with a power of 4. If you look at the back of the assignment sheet, you have those tools, pools, mules, rules of exponents. And there's Zen, Yen, Hen, 10 of them. One of them says a to the m over a to the n is a to the
n minus n.
Good. We subtract the exponents. So if that's a 5 and that's a 1, then this is 5 times 1. That's how you get x to the point. So here's what I'm after. Your answer is going to start 1 degree less than the numerator, 1 degree less than the dividend. So since we're dividing into an x squared, this is going to be, and I'm going to clean up my answer in a minute, this is going to be the coefficient. It's going to be 1 times x to the first. We're dividing x squared, 1 times x to the first, plus 2, and then we have a remainder of 1 over x plus 3. So on your On quiz, it's gonna be at the bottom of the box, x squared. Plus 5x plus 7 divided by x plus 3 equals, so you clean up your answer, and your answer is gonna go 1 times x, well, that's just x, plus 2, plus the remainder over x plus 3. Just for kicks. What did this answer equal? What did this one? What was this answer for the first one? Plus 51 over x plus 4. Okay. What's k?
-4.
-4. So put -4 in the box. The coefficients, we have a 1, we have a -8, we have a 3. They're all aligned. We bring down the 1. Bring on down, 1. We multiply 1 times -4 is -4. Then we add -8 plus -4, that's -12. We add -8, -4 make -12. And then we multiply -12 times -4. -12 times -4 is positive 48. So you got to really keep track of your signs. And then you add again. 3 plus 48 is 51. My remainder. We started with x squared. So the answer is going to start with x to the first. This is going to be 1 times x to the first, which is just x. And that's going to be my constant, -12, because you go from x to the first, x to the 0. And then I have the remainder of 51 over x plus 4. Synthetic division only can work, will only be allowed if you divide by something that looks like an x minus k, which means it can only be a binomial, 2 terms. And this has to be a 1 times x to the first. It has to be a 1. It has to be an x to the first. You can't divide by a 3x. You can't divide by a x squared. It has to be a 1 times x. So there is a restriction on synthetic division. Now, past this class, yeah, we have some ways of doing some manipulation. We don't always try to. But that's another hill to climb. You just got to get the basics down. Is synthetic division faster? Absolutely. But only under certain circumstances. The answer starts 1 degree less. 1 degree less. Your bonus questions today. Double click, see if I'm lying or not. I hope I wasn't. Your bonus questions today are not going to be both scrambled and missing parts, missing terms. Your bonus questions will just be either scrambled, so you make sure you rearrange, or it'll be missing some powers, and you got to make sure you fill in the zeros, placeholder. But it won't be both like these examples. Now, on your test, the bonus questions would look more like this. Okay? And on your test, you would have what you're going to see as your bonus questions on today's quiz actually be test questions. On your test, you have 4 division questions. 2 long, 2 synthetic. 1 where it's nice, like this, and 1 where it's like the bonus you're going to see today. Then you have a couple that are on the bonus. The next test is the last time you're gonna have bonus questions. Okay, it's the last time you're gonna have bonus questions. The final has no bonus. So you wanna gather up all the points you can get. So here we go, long division, before we do it, what's the biggest power? Rewrite this thing.
It's a four.
So we're gonna start with x to the 4. Four, who's next?
Minus x to the 3 third.
X to the 3rd minus the x to the 3rd. Make sure you have your signs. Checking them off. And then a,
Plus 2x.
nope.
Your x to the 3rd.
Right, we're looking for x squared. We don't have an x squared, so we need a placeholder. We need an x squared, so we need a plus 0x squared. And then an x to the 1st. There's my x to the 1st, plus 2x. And then an x to the 0, the constant. So 4, 3, 2, 1, and then a constant, which is an x to the 0, my plus 4. So all the power should be accounted for, 4, 3, 2, 1, 0. And in the right order. Make sure the signs are right. It's a positive 4, it's a positive 1x to the 4th, it's a negative 1x to the 3rd, it's a positive 2x. Because if you transpose the signs incorrectly, you mess up the whole thing. And we're dividing by x minus 1. So we're supposed to do this one with long division. So out here, the divisor is x minus 1, and we're dividing into. That's not going to be. It's not going to be enough room for this one. Run right into that. You guys have enough room in your box because you don't have something right next to it. You're not trying to write big enough for the camera to count. So x minus 1 out here. And x to the 4th minus x to the 3rd, plus 0 x to the 2nd, plus the 2x, and then the plus 4. So focus on this, focus on that. What times x is x to the 4th? X to the 3rd. So we're going to start here in the column where x to the 3rd. And we're going to have to multiply times both terms so you can distribute x to the 3rd times that x minus 1. And we get x times x to the 3rd times x to the 4th. X to the 3rd times negative 1 is negative x to the 3rd. So when we distribute, we get x to the 4th minus x to the 3rd. So we subtract. This better cancel out. That's why we chose x to the 3rd. Does. And then look right here. Negative x to the 3rd minus a negative, it's a positive. What do I get when I have negative x to the 3rd plus x to the 4th? 0. It cancels out as well. And then trouble happens. The next term is 0x squared. But you know what? Because it's 0, people don't write it down. It's a placeholder. It's a placeholder. So keep its place. If you want things to work out correctly, the next thing you're going to do is you're going to bring down that positive 0x squared plus 2x plus 4. And you know what times x is 0x squared. What times x is 0x squared?
You're right.
0x. So the next one we have nothing in the x squared column because right here you have 0x to the third. So you have nothing in the x to the second column because you have no x cubes to get. And you're going to have nothing in the x squared or the x in the first column because you have no x squareds. The only thing left to multiply and get is a 2x. Because that's all you have left. You don't have any x cubes. So in the x squared column, what times x is x cubed? 0x squareds. And then in the square column, what times x is 0x squared? 0x. And then now we're in the x in the first, 2x plus 4. What times x is 2x?
2.
That's it. 2 times that x minus 1. 2x minus 2. Zero. What does this become?
6.
6. Good. 6. Subtracting negative becomes positive. We get a remainder of 6. So the final answer, we have an x to the third. You don't put these in there because all we want is the actual quotient. We have an x to the third, 0x squared, 0x to the first, and then we have a plus 2, and then we have a remainder of 6 over the x minus 1. If this was your synthetic division, what's k?
1.
Positive 1. The 1 goes in the box. That box. Coefficients. We have a 1, negative 1, a 0, a 2, and a 4. Bring down the 1. Multiply 1 times 1 is 1. And then we add. What's negative 1 plus 1?
0.
0. And then you multiply. 0 times 1. 0 times 1 is
0.
0. And then you add. 0 plus 0.
0.
0. 0 times 1.
0.
We get 0. 2 plus 0. 2. 2 times 1. 2. And then we add. We get 6. It started as x to the 4. So what's the answer starting with?
X to the third.
So 1 times x to the third, 0x squared, 0x to the first, plus 2. And then a remainder of 6 over x minus 1. You cannot use synthetic division in the direction, say long division. You have to do the long division. And vice versa. Now, can you check your answer with synthetic? Absolutely. I would do it on the back so I don't get confused when I'm grading your test. Very quick. And or your test. Make sure it's in the right order. What's the biggest power?
2x to the 4.
So 2x to the 4th. Do we have any x cubes?
No.
Go fish. So we get 0x to the third. Do we have any x squared? No, go fish, so we need zero x squared. Do we have an x to the first?
Yep, 4x.
So we have a plus four x. And then a minus 3. Divided by x plus 1. So what is the k dot? Negative 1. All right, now we gotta be careful this one. Whenever we deal with negative numbers, things go wrong. Negative 1 goes in the bottom. Coefficients are 2, we got a 0, we got a 0, we got a 4, we got a 3, negative 3. And I'll be honest, when we have zeros, that can sometimes be daunting. I was about ready to go 0 times 1 is 1. I almost did. And not because I wanted to see if you're paying attention, I almost thought it was. Bring down 2. We get 2. We multiply 2 times negative 1 is what?
Negative 2.
Negative 2, and then you add. Now you don't have to keep showing these arrows, but I'm just showing you direction. We add. 0 plus negative 2 is negative 2. And then we multiply again. Negative 2 times negative 2, that's going to, or negative 1. We'll make it up a little 1. That's positive 2. Then we add. We get 2. And then we multiply. 2 times negative 1. So there's negative 2. And then you add. 4 plus negative 2 is 2. And then you multiply. 2 times negative 1. Negative 2. And then you add. What's negative 3 plus negative 2?
Negative 5.
Negative 5. See, a lot of 2s. 2s are wild. It was x to the 4th divided by x, so we start with x to the 3rd. 2x to the 3rd minus 2x squared plus 2 times x to the 1st, and then a constant that is a 2, and then here's a good one, a remainder negative 5. Plus, just put negative 5 over x plus 1. Just the remainder over the divisor. When you do the synthetic division, when you get to your terms down here, and you start 1 degree less than the original dividend, I start with x to the 3rd. When I run out of the divisors, I should have gone from x to the 3rd down to x to the 0. If I have an extra term, let's say I had, instead of 4 numbers here, I had 5. There's something wrong. I mean, and I'm not counting this. I'm counting 5 here in front of me. Something's wrong. Because if I have an x to the 4th and I divide by an x to the 1st, the denominator starts with an x to the 3rd. And if I have x to the 3rd, I'm going to have x to the 3rd, x squared, x to the 1st, and then a constant. And if I have a remainder, then a remainder. If I have an x to the 5th and divide by x, I'll have an x to the 4th, an x to the 3rd, an x to the 2nd, an x to the 1st, and a constant. If I have x squared, divided by x minus 2. Well, x squared divided by x is going to start with x to the 1st. I'll have an x to the 1st and a constant. There's 2 terms. Okay. In other words, that had 3. When I divide, I'm going to have only 2 answers for 2 terms. This had, with all the parts here, 1, 2, well, I'm not going to count that one because that's good. This had 1, 2, 3, 4, 5. My answer has 1, 2, 3, 4 in the quotient. And you can track it. Before we transition from this class into the Pinnacle class, I will put up a couple of more practice problems.
that we'll go over at the beginning of 10 o'clock, and then we'll get into chapter 4 stuff. So we're going to preview some chapter 4 right now. Exponential growth. That's what this chapter is about. Exponent. Exponential equations, exponential functions. Say you're an independent contractor and you have a job offer and they're willing to pay you in 2 different ways. So you have to decide. One of those weird kind of propositions. And basically what you decide is going to be the telltale sign as to whether or not this, this potential employer is going to make a decision as to whether or not they're going to hire you. Are you smart? Then again, maybe if you make the right decision, they don't want to pay them. Would you rather be paid for 6 weeks, 5 days a week, $100 each day? I'm sorry, $100 on the first day, and then on the second day, you get 200, and on the third, you get 300. So basically, every day you're going to get an extra $100. So it would look like this. They're going to pay you $100 on that first day. You're going to get $200 for working the second day. You're going to get $300. Not that you're just paying. You're not actually getting this day and then this day you get 100. So it's a total of 200. After day 2, you have $300. On the third day, they're giving you 300. So after day 3, altogether, you now have $600. On this day, they're going to pay you $400 just for that day alone. So now, after 4 days, you have $1,000, okay? Make sense? Hypothetical, not real world. Who knows? Who knows that job in your head? Or on the first day, you get a penny. On the second day, you get 2 cents for that day. On the third day, it's gonna double. You get 4 cents. On the fourth day, we'll get 8 cents. So it's the amount you get is gonna double every day. Starting with 1 penny. So you get 1 penny, 2 penny, 4 penny, 8 penny. Which way would you want to be paid? Now, not just a matter of guessing. Just by looking at it. The math that you probably would want to do in your head is, I'm taking the $100 because that's the easiest math to probably apply.
But the penny is per hour or?
No. Penny is per day.
Per day.
For just one day, the first day you get a penny.
Per day.
We're going for the whole 6 weeks. So the question is, what's going to be your best interest? And if you don't, let's say you have 3 seconds to think about it. Maybe you're going to go with $100 because you don't want to think about it. Because at least you know, here you're going to make $500. Here you're going to make, well, if I'm getting an extra $100 every day, 600, 700, 800, 900, $1,000. What's $1,000? 1,000. But again, it's cumulative. So if this is $500, that's $1,500 you made that week. So you are adding it all up. After 4 days, I mean, you've made 3 cents, 7 cents. You've made 15 cents after 4 days. It's not bad. $0.15. 32. 54. $1.28. $2.56. And we're up to $5.12 after 2 weeks. Rolling and going. $10.24. $20.24. $20.48. $40.96. $81.82. No. Yeah, 81.82. I think that's right. Is that right? I don't want to get it wrong. Yes. Double check my math. 2 to 1, 18, that's 19, that's 92. 192, all right? Okay. And then we double that here after 3 weeks. 81.92 is going to get double, so if you put 4 to 8, 31, 3, $163.84 on that day 15. And on day 15, so we're making $1,000 for this day. 1,100, 1,200, 1,300, 400. We're making 1,500 for that day alone. We're only making 63. But on this day,
$327.68. $655.36. I'm hoping I'm doing my math right. 72, $1,310.72 for that day. So on this day, we're making $1,310.72. They're making $1,500, but remember, it's 1,500 plus this day was 14, plus this day was 13, plus this day was $1,200. So again, they're adding up all the other days. We're just barely making 1,300 for this day, plus all the issue, plus that penny on the first day. Two, four, 26 over 261144. Is that right? I double it. That's 2,611.
That's 21,
Was it?
2,621 for the
Or
4.
21?
This 4 cents.
2,621.44 cents. Eight, two, we go four, we go two, five. So on that day, we're making $5,242 for just that day. And if we double that, remember, we start with the penny. On this day, we're making $10,485.76. $10,000 just for this day right here. $10,000, $485, or $10,485.73. We start with a penny. On this day, they will make, well, that would be $2,000. So on this day, they would make $2,100. Yeah, they're gonna add them all up, but right here, we're making 10,000 for that one day. Now, I don't want to punch in a whole bunch. I want to keep doubling. It's got to be a formula, and there is. It's called an exponential equation. We're doing to the 0.1 to the penny. What are we doing to the next number? We did what to this times one? 2 times 2. And then we took this answer and we multiplied by 2 again. And we took this answer and we multiplied by 2 again. Okay. On day 1, when t was equal to 1, it was 0.01 times 2, not to the first, because if it was 2 to the first, this would be 2 cents. It was 1 minus 1, it was 2 to the 0. And 2 to the 0 is what? 1. So that's why it's just 0.01. Then on the second day, it's 0. It's this answer, or technically, it's the penny that we started with, times 2 to the 2 minus 1. And that's how we get 2 to the first. A penny times 2 to the first, and that's how we got the 2 cents. 0.01 to get 4 cents. We took 0.01 times 2 squared, but it was the third day. So to get the third, using the 3 minus 1 gave us the 2 squared. So in other words, on day 1, we raise it to the 0 because it's the first day. It's it's day prime. On the second day is basically the first day is. This is where it gets weird. It's called the initial day. The initial day, it's a zero. The initial day, we raise it to the zero power. But it's actually one, so if you get the one, it's t minus one. Now, there is a way to convert it, but for right now, we're just gonna leave it like that. How many days? What day is it?
30.
Day 30. So our penny on day 30. 30 minus 1. So that would be our penny times 2 to the 29. And I'm just trying to show you the power of a exponential equation. See it? There we go. So 0.01 times 2 to the 29th power. So on that last day, we will make $5,368,709.12 for that one day of work. On that last day of work, if we take the 100, well, let's see, that was 500, that's 1,000, that's 15, 2,000, 2,000. They're going to get $3,000 if they're taking $100 increments at a time. But we're going to get for that one day 5,300. We start with a penny. That's how quickly exponential growth happens. Instead of just adding an extra 100 every day. Exponential growth versus, that's the other one is linear growth. Exponential growth is very quick. When something grows exponentially, when you hear that phrase, that means stand back. When you hear about a virus growing exponentially, one cell becomes two cells become four cells become eight cells become 16 becomes 32. Population growth. Okay. Radioactive decay. That's all exponential growth. And an investment is an exponential growth problem. How much you owe on a loan can be in your payments is considered an exponential problem. Because it's based on time as a power. This problem has also been described as if you put one tiny grain of sand on a chessboard. On a chessboard, it's 8 by 8, so there's 64 squares. On the last square, there's not enough room on the base of the earth to hold all the sand. Okay, because that would be 1 times 2 to the 63rd power, or basically 2 to the 63rd. 2 to the 63rd power is this number. What is this E mean right here? 9.2233 E 18. Exponential notation. Scientific, actually, scientific notation. I like mix scientific with exponential. And then Freud stepped in. 9.2233720037 E18 times 10 to the 18th power means you take this
and you move the decimal 18 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you get 9, 2, 2, 3, 3, 7, 2, 0, 3, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 more zero. 1, 2, 3, 4, 5, 6, 7, 8, 9. This is how many grains of sand you would have on a checkerboard, chessboard, whatever. So hundreds, thousands, millions, billions, trillions, quintillion, 9 quintillion, 223 quadrillion, 332 trillion, 37 billion. 80%. Just because we don't. Okay. Plus, by just going one, and on the last one, doubling the time. That's exponential growth, and that's what we do in chapter 4. I hope you have a calculator, because we'll be doing some punching up here. All right. I'm going to put up some problems so we can review one more time with long division, synthetic division at the beginning.